Express the combined area of 4 regions as a function of x. We have 400 feet of fencing used to divide a rectangular area into 4 equal regions. So I've set the length of one of these mini rectangles as x and the width as y. We can see there are 6 x's and there's also 6 y's. 6x plus 6y equals 400 feet of fencing. Let's isolate the y. I'm going to first start by subtracting 6x to the opposite side and then dividing by 6. Now we need to share the 6 with both the left and the right, so 400 over 6 minus 6 over 6x. So isolating the y, we can reduce this down to 200 over 3 minus 6 divided by 6 is 1. Or you may choose to divide this to get 66.6 repeating minus 1x. So let's come up here. Let's express the combined area. So let's figure out what the area of one of these is, and then we're going to multiply it by 4. So if I look up top, remember we need to write this as a function. So area, now we have 4 rectangles. Let's now think about just one of these. We have right here a length of x, and now the width, I'm not going to put y, I'm going to put what the width is equivalent to. I could use this one, or I could use this as well. That would be just fine. And so I'm going to stick with 200 over 3 minus 1x. Find the domain. So I'm going to set each of these equal to 0, and then I'll show you. Okay. So I'm going to set this first part, which is 4x equal to 0, and I have x equals 0. Then I'm going to take the second part, 200 over 3 minus x equal to 0. First I'm going to subtract 200 over 3, so negative x equals 200 over 3. It's subtracted, it's negative. Divide both sides by negative 1, and the other is 200 over 3. So I believe the domain has to be greater than 0 and less than 200 over 3. Now I've taken this equation, that's when I press pause, and I plugged the equation in, and then I did a zoom fit. And now let's check. Second trace value, second trace value. I'm going to start by doing 0. We can see 0 is a solution. Second trace value, I'm going to do 200 divided by 3. And we can see this is also a solution. So I feel confident with this answer. This is algebraically how we're going to do this. Find the area when the length of one rectangle is 10. So when this is 10, what is the area of one rectangle? Let's see. Sorry, let me go back here. Find the area when the length of one rectangle. Sorry, we want the entire area, so I use this formula when I know that x is 10. So I could substitute 10 in here, and we'll see how to do that. Or to simplify it, I take this second trace value, and I want to know when x is 10, what is the area? It's 2,266.67. So 2,266.67, and that is feet squared. The other way to do that would have been up here, 4 times 10, and then we have the fraction 200 divided by 3, subtract 10, and we get the exact same output. Find the maximum area of the large, so the entire. So maximum, second trace value. Maximum, we're going to go somewhere to the left, pressing enter, somewhere to the right of the highest, which is somewhere around here, and then a guess back to where is the highest. So this is our maximum, 4,444.44 feet squared. Find the dimensions of the smaller. So this is my x value. This is my x value. So 33.3 repeating. Now I need to know what the y is. So remember, here is my y, and I know x is going to be 33.3 repeating. So I'm going to do 200 divided by 3, subtract 1 times 33.3 repeating. And we get 33.3 repeating. Let's see. 33.3 repeating. That's of each smaller region.